In this video, we're going to be talking about something called the addition rule. And again, starting out with some definitions. A compound event is any event combining two or more simple events. So this would be the probability of event A happening or event B happening. And whenever we're using the word or, it means the probability that A is happening or the probability of B is happening, or they could both be happening at the same time. So that's what or means. The notation that we use for or is this symbol. It looks like a big capital U, and it's the union symbol. It means that we're joining these two events together. So this is the probability that event A has occurred or event B has occurred, or again, both of them have occurred. Something called a disjoint or mutually exclusive event are two events that cannot occur at the same time. So if two events cannot occur at the same time, we refer to them as either disjoint or mutually exclusive, so that these words mean exactly the same things and we can use them interchangeably. So if I say that two events are disjoint, it means that they are mutually exclusive. Or if I say that they're mutually exclusive, it also is the same as saying that they're disjoint. Looking at this using something that we call Venn diagrams. So these are called Venn diagrams, and the box or the rectangle is representing everything, and then the circles are representing events A and events B. So the pink circle is representing event A, the yellow circle is representing event B. When we're talking about the probability of A or B, probability of A or B, so that's the same as the probability of A union B. So that's the joining of the two sets together. And so one way to think about this, so here's the probability of event A is this circle here. And then the probability of event B would be represented by this yellow circle here. And so if we just add those two probabilities together, then what happens? So what happens is this part in the middle, we added it in for the probability of event A, but we also added it in for the probability of event B. So this piece right here in the middle got added in twice. So let me pick a different color. So this part in the middle gets added in twice. And so we don't want it to be added in twice, and so to eliminate the fact that we added it in twice, we need to subtract it off once. And so this part of the circle is the probability that A and B are occurring at the same time. It's their overlap, and so we need to subtract that off. And this has a notation, and it's the intersection. And so the other way to denote this would be using this intersection symbol. So this formula is not really going to be all that important. Generally, I think it's easier to compute these probabilities using an intuitive sense versus using this formula. And when I do them, the examples in the lectures, I'll use the intuitive idea behind it instead of the formula. In the next Venn diagram, we have another representation. So in this first example, since A and B overlap, these are not mutually exclusive. Because the two events overlap. In this Venn diagram, the events do not overlap, and so these are mutually exclusive. And when two events are mutually exclusive, the probability of A or B, so that's the union, probability of A union B, is exactly the same as the probability of A plus the probability of B. So again, these formulas, you don't need to worry about memorizing them. I won't ever ask you to use them. And computing these probabilities intuitively, I think, is actually easier than trying to use these formulas. The next Venn diagram is just depicting complement of an event. So A in the yellow is our event A, and in the pink we have the complement. So again, remember that the complement is everything that's not an A. And so here is how you would compute a probability with complements. So in our first example, we're going to use this table. We saw this table before. There is a total of 1,000 people in this table. So if you add 44, 90, 6, and 860, that total is 1,000. And so we're going to compute some probabilities using this table. If a subject is randomly selected, calculate the probability that they had a positive test result or used drugs. So either they had a positive test result, so positive test result are all of these people, or used drugs. And so used drugs is the first row, so we need to add in these 6. And then you divide by the total. And there are a total of 1,000 people. And so this would be 140 divided by 1,000. And so that's 0.140 if you go to 3 decimal places. Just be careful on your homework and quizzes that you really pay attention to how many decimal places are being asked for. Most of the time we want 3 significant digits. So remember, significant digits, you start counting after the first non-zero digit after the decimal place. So here's our decimal point, and our very first digit is a non-zero digit. So that's where we would start counting our significant digits. So this is 1, 2, 3 significant digits. If a subject is randomly selected, calculate the probability that they had a negative test or did not use drugs. So a negative test, well, let's pick some other color. So let's pick blue. So negative test results are these people. So that would be 6 plus 860. Plus we also want the people who did not use drugs. And so the number of people who did not use drugs are these 90 people. So we need to add on another 90. And then we want to divide by our total number of people, which is 1,000. And so that's a total of 956 divided by 1,000. And as a decimal, that's 0.956. The next example, if a subject is randomly selected, calculate the probability that they used drugs. So for the probability that they use drugs, so used drugs is the first row of the table, so we want to choose those people. So that is 44 plus 6, and then divide by 1,000. So 44 plus 6 is 50, and then divide by 1,000 gives us 0.050. And again, Be careful of how many decimal places you're being asked to round to. If you're asked to round to 3 decimal places, you need to make sure that you tack that 0 onto the end. And in the next example here, if a subject is randomly selected, calculate the probability that they had a positive test result. So let's go back up to our table, and we want this time people who tested positive. And so positive test results is just this first column in our table. And so that's 44 plus 90. And then divide by the total number of people, which was 1,000. And 44 plus 90 is 134. Divided by 1,000 gives us 0.134. Alright, so that's it for this lecture video. I hope you guys are all having a great day. Thanks.